is geotrig, lesson 16, day 2. We're going to talk about abstract equations. I'm going to start off, guys. I'm going to write something on here that you guys have done before. This is what do we call this? Every single one of you guys should not be hesitating right now. You guys should be able to tell me what that is.
Like simple standard or something.
Simple standard, no.
No, it's like
I like standard.
Standard equation.
Standard form of a line. This would be standard form, guys. This is scary. This is standard form. I know you guys have done this because in Algebra 1 is the first time you start learning about linear equations. And you guys start off with something like this. And then you will usually transform it into the other line equation, which most of you guys like. What would that be? Y equals mx plus b. Right? One standard form, the other one is slope-intercept form. But what you guys should also recognize is that this form and that form are interchangeable. One is solved for the constant, standard form, and the other one is solved for y. It's solved for the y equals, right? So, that was one of the first times, guys, that you guys would have solved equations probably for another equation, or another variable, instead of just solving for one particular variable in terms of a number. We are, at this point, we would have solved for y, this equation, y, in terms of a, x, b, and c. And it would be in this form. Now, granted, the variables change because it means something differently. But would you guys be okay with me saying, hey, I can subtract an ax, or a and an x to the other side? An a times x, right? So you guys would say, oh, that's no problem. That's by equals a negative ax plus c. And then you just divide everything by b to both sides, obviously. And so y is equal to negative ax plus c over b. Would you guys agree with that? Have you guys done something like that before? Absolutely. Right. Guys, that's an abstract equation. You have now solved for a different variable within the problem. It's no different than when you go up to our problem for today and say solve for c. That means you got to get c by itself and everything else on the other side. The biggest thing that you have to remember is what you do to one side, you have to do to the other. There's no exceptions. Because if you don't do this to both sides, you will have just changed the equation. I'm going to take away all that green stuff. And now let's actually start to do this problem. The problem we have is y equals b times quantity a over x plus b over mc. I want to solve for c. And if you notice, c is it's kind of nice. How many c's are in this whole entire problem? Just one. That makes our life a little bit easier, actually, because I only have to worry about the one thing. So then you just have to start looking. What is not C? Well, everything else. So, what are some things that I can start to get rid of? I can't get rid of the m first. I think I can get rid of v.
Oh, yeah.
Now, there's a couple options with v. You guys are like, oh, it's outside a set of parentheses. Maybe I should distribute the v. Is that a wrong thing to do?
No.
Not necessarily. Is it the most efficient way to handle v? No. It's v times a group that has something you want. So to get rid of v, the easiest way is to divide both sides by v. So y over v equals ax plus b over mc. Is that okay? Now, there's options for this. I have 3 fractions, and c happens to be in the denominator of one of them. One option is get rid of all the denominators by multiplying both sides by the least common denominator, the LCD. That's one option. The other option is the fact that one of the fractions on its side with c doesn't contain any c's in it, does it? Can I just get rid of the plus a over x? And how do I get rid of a plus a over x? You subtract it. From? Both sides, that's an a. It looks like a 9, doesn't it? So these are gone. So now we're left with y over v minus a over x equals b over mc. I want to get c by itself, guys. We could multiply by m. That'd get c by itself on the bottom, right? But I don't know if that necessarily would help us yet. Multiply by what? 1 over b? Yeah. That would work, but then I should also multiply it by m. So m over b. But if I did that, okay, let's just do this. If I did m over b to one side, I'd have to do to the other side. You guys, I hope, can agree that the b's and the m's, they cancel. And I'm left with 1 over c. That's not really what I wanted. But, on the other side, I probably should distribute that in. How do I multiply fractions again?
Top times the top and the bottom times the bottom.
You got our top tops, bottom bottoms. So, this becomes my over bv minus am over dx. Now, what can I do? I have a fraction, subtract a fraction, equaling another fraction, but the fraction at the very end is the one that has the piece I want. But it's on the bottom. Now, this is kind of interesting, this over here. I got 2 fractions being subtracted. One really thing we could do here is get a common denominator. And if I got a common denominator, I would have a fraction, right, equaling a fraction. And when you have a fraction equal a fraction, what can you do? Cross multiply. So would that maybe be a good option? So how can I get those 2 fractions on the side to be a common denominator? What's missing on this one? An x. So I need to put there and there. This second one is missing v. So mxy minus amv all over bvx. I'm just trying to put things in alphabetical order. I may actually be wrong, but is that okay?
Yeah.
Okay. There's actually a couple options even here. I think most of us would say, oh, just cross multiply though, right?
Can't you cross out the V's?
You can't cross out the V's because there's not a V in the first group. You can't be able to factor out a V, right? So if I cross multiplied, I'm going to run out of room here. Let me shrink this up. Okay, so we have this. Now I can cross multiply. We hopefully would see this would be C times mxy minus amv, right? Equals
X would be,
bvx,
whatever.
multiplying corners together. And to get C by itself, what do? Divide by
Divide by M, X, Y minus,
And
V. It's a V, not U.
V, like,
There's C right there. Okay, that, what we did last time, didn't necessarily use the fact that we could use the LCD on some of these. So here's a bigger one with numbers and letters. Not a big deal. Remember, you treat all variables like numbers anyways. So I'm going to treat this the same way. I wanted to solve for L, which L now is this thing way down here. When I write it, I'm going to use a capital L instead of that lowercase l so it doesn't look like a 1. Okay? So I want to solve for this, which is inside again by itself. Now, this is what I propose. I propose that you still get rid of anything that's outside of your parentheses. So that means get rid of the 3 over 2t, which means multiply both sides by 2t over 3. 2t over 3. 2t over 3. Hey, a lot of things cancel out here. Those cancel, but so do the 3's. So I get
2t over s,
2ts
2ts
equals 8dl minus 3md. Is everybody okay with that? Now again, the thing I want is on the bottom. If it was on top, it'd make my life a lot easier. Bless you. So let's make this thing go to the top. Let's take L to the top by multiplying everything to get rid of the denominators. Make nothing in the basement. What is the LCD of this problem? It is LD. Now remember, officially, I would multiply both sides, right, by LD. Which means, after I distributed it in, it would be to every single term. Yes? The same thing with the complex fractions. So I'm going to take those away. And what if I just, so in my mind, that's what I'm doing. So I write it next to each one. I remember, I do this so that I can cancel things every single time. It makes me feel good when I can cancel. I'm assuming it does for you too. Good. So LD times 2TS, can anything go together? No. I'm going to try to put my coefficients first. Numbers always go first. And as best I can, I'm going to put it in alphabetical order, just to standardize things. Does it have to be? No. Hey, what happens to the L's in the next one? They cancel out, and you're left with what?
8L, D.
There is no L. The L's gone. So 8D squared.
Oh.
And now the next one, the D's cancel. Boom, boom. So minus 3 LM. Guys, does everybody see that what we did was all legal moves?
Yes.
Now, somebody might be asking the question, Mr. Konchak. We started off with only one L. Now we have two. Are you kidding me? But guys, we also started off with fractions, and now we have no fractions. Okay, I like Tyler's thinking of I can divide. But, guys, I'm not going to necessarily divide. I'm going to use a better word that starts with F.
Foil.
No, factor. Which factoring is dividing. I am going to get the stuff that has the L's in it together so that I can factor out an L. Which ones have the L in it?
2DLST.
The first and the last term. So I'm going to add 3 LMs to both sides to get it away from the 8D squared. So it's 2DELST plus 3LM. They're not like terms. I can't put them together. Does everybody see I just moved the 3LM to the other side?
Yep.
Look, there's an L in both of these. So I can take an L out. So if I take an L out, what's left? 2DST plus 3M. It's a little bit larger. And to get L by itself, the last step is divide both sides by the thing inside that parentheses. 2DST plus 3M. 2DST plus 3M. So L equals 8D squared over 2DST plus 3M. Boom, it's done. One guy's method, we just got fractions equaling fractions cross-multiplied. This time, we multiplied both sides by the LCD just to get rid of fractions right away. Your choice on how you want to do that. Sometimes you can set it up by dividing right away. That sets up a complex fraction, which then you should also fix because you can't leave things in complex form that way. Your homework for tonight is 8 and 9, which is exactly the two problems we did. 12 to proof, and I want you guys to do long division to kind of bring back, because that's what we're going to do on Monday, is long division, but with polynomials, but you have to use the same process. So, I want you to divide 2,589 by 16, but do it longhand. No calculator allowed. Have a fantastic weekend. Go Tridents.